Good morning, everyone. So what we've got here is a bit of a different concept. So we're looking for the limiting value of a sequence as n tends to go to infinity. Okay, so imagine that you've got your sequence and it goes to infinity. What would actually be the limiting value of that sequence? Now, as you can actually see here, say I've got this question here. I've got 6n over 2n plus 1 as n goes to infinity. Tends to infinity even. Now you can actually see here what they do straight away is to get rid of the 1. Well, obviously, the 1 comparing it to infinity is not important, so therefore it's left with 6n over 2n, which is equal to 6 over 2. So that's why for this question here, the limiting value would simply be 3. So we're looking at, so the value of the sequence approaches the called limits, yeah? The value of n tends to infinity. So it's a very, very weird concept. Now, I don't want you to be thinking straight away how I'm just getting rid of numbers, okay? So let's do it correctly mathematically. So say I've got the question of n squared plus 4n of n squared plus 8 as n goes to infinity. Now, for this question here, all they've done, as you can actually see from the example, they've gone to n squared over n squared equals to 1, okay? But how have they done that? Okay, that is the problem, how they've done that. So, the way I want you to be thinking about it is you're always going to be looking at your biggest term, okay? So, your biggest term that you've got here now is only quadratic, okay? So, you've got n squared. So, as n tends to infinity, okay, so n goes to infinity. So I want you to divide every single term of that sequence by n squared, because that is the biggest term. Now, eventually, you won't need to be doing this, okay? You won't simply need to be doing this, but I'm showing you as to why they go simply from that to this answer. So n squared over n squared equals to 1. 4n over n squared equals to 4 over n. N squared over n squared equals to 1. 8 over n squared. Now, what I want you to realize is that the bigger the number in the denominator, so the more you're actually increasing a number, so you can actually see if you've got 1 over 2 is 0.5, but 1 over 10 is 0.1. 1 over 100 is 0.01. So, as you're increasing your denominator, what is actually happening to the value? It becomes smaller and smaller. So if you've got an infinite denominator, this value here, 4 over n, will therefore be equal to what? It'll be equal to 0, because as n goes to infinity. Same here, that'll also be equal to 0. That is why they've not included it there. So therefore you've got 1 over 1, which is 1. So n is simply the limiting value for this. So n equals 1 is the limiting value for this. Let's have a look at the other example again. So you've got n plus 7, n squared plus 7. Work out the limiting value as n tends to infinity. So the biggest thing we've actually got again is this, quadratic. So I'm going to divide everything by n squared. Obviously, eventually you will get to this stage where you can just go straight away to the answer, but I want you to understand what we're doing. So this is 1 over n plus 7 over n squared over 1 plus 7 over n squared. And what have we got? Well, we know that this is equal to 0. We know that this is equal to 0. This will be 1. We know this is going to be equal to 0, okay? Because you're thinking as n goes to infinity. The bigger the denominator, the smaller the number becomes. So therefore it's 0 over 1, so the limiting value is 0. Same again here, what they've done is, as I said, you don't need to do all the working out that I'm doing, yeah? Eventually I want you to understand that you can simply go to, if n tends to infinity, the n plus 1 over n plus 4 becomes n over n, which is equal to 1. So the limiting value is simply 1, nice and clearly. Can you try these questions please for us? Pause the video and I'm going to give the answers for you. And what have you got here? You've got some exam questions on it. So these are the answers for the first questions. And please mark your work.